think we're going to get started. So thank you all for joining today. We're super excited to have such a big group come out for this Finding Energy Savings Opportunities subsector workshop. We're looking at the manufacturing sector today, and I'm really excited that we have John Feldman here and Daniel Jostling. We're going to do more proper introductions, but they are our subject matter experts for the presentation today, and they're going to talk through some of their experiences finding opportunities in manufacturing. Also, thank you to Fatema for joining us to support the workshop. I'm Amanda. I'm a skills coach with Goldfin Consulting, and I'm super excited to be presenting to you all here today. So today's objective is to help you find opportunities in your facilities and operations. And we're going to start off with a bit of a general discussion on how you can go about finding those opportunities. Then John and Daniel are going to share some of their experiences with manufacturing facilities, including common opportunities and working to uncover high impact opportunities. Lastly, we're planning on leaving a good chunk of time for you to ask questions to John and Dan. It's a great opportunity to take advantage of their knowledge and expertise. So hopefully you have brought some questions about opportunities at your own facilities to get the most out of today's session. So this session will be interactive, as I mentioned. So even before the Q&A, there'll be opportunity to contribute. So we'll taking advantage of all the Teams tools like the chat and the Q&A. If you have any questions or things you'd like to share as we go, please do raise your hand or feel free to type in the chat. So we also have a participant workbook that sort of goes along with this workshop today. It summarizes some of the key materials and includes some space for you to write down notes that are relevant to you. A link to the workbook can be found in the chat. I think Fatema is going to drop that in there right now if she hasn't already. When you open it, please click File, Download, and save a copy so you have your own version to write in. I just want to ask and make sure that if you are unmuted, if you can please mute yourself because we do have some background noise coming through. We just want to make sure everyone will be able to hear today. Okay, so let's see what we got for results on our Menti question. So it looks like folks are mostly focused on some more challenging projects, not as many looking at like the low-hanging fruit or some low-hanging fruit with a mix of some of the more challenging projects. So I think especially around those challenging projects, the more specific projects, we hope you have some questions that you can bring. And if we're not able to answer them today, we're going to do our best to get back to you on them. So our next question is how do you currently identify opportunities within your operations? And what do you do to find those opportunities? So please go to menti.com again and use the code 2591-1288 to answer this question. What are you currently doing to find opportunities? And we'll just let folks enter in their results there.
Claudia was saying that use info.
Got some answers coming through. Great. So it looks like our biggest result is around reviewing energy and equipment data. That's so great to know that folks have some strong data already that they're using, and John's definitely going to get into how to use data to find opportunities. Some folks are doing energy audits, so walkthroughs and auditing of their systems and equipment to find opportunities. Regularly scheduled energy hunts, so hopefully integrating some staff in those energy hunts, employee suggestions, vendor recommendations, and then we have some folks doing some other things, which maybe we can get into as John is asking some of his questions in his presentation. Great, thank you all. So these approaches here to identifying opportunities can really be loosely grouped into 3 categories. So our first category is around data analysis to understand your equipment and processes and see where waste is occurring. The next opportunity we're going to talk about today is around site investigations. And some of you already mentioned doing energy hunts and energy audits. So site investigations are where you're going out and looking at your facility and processes and equipment and seeing how they're operating and where there can be improvements. And then finally, we have employee strategies to get them engaged and really support your effort. The most important thing to consider with these practices to identify opportunities is that you really should be using a mix of all 3 categories. Otherwise, you might not be getting a complete understanding of your opportunities. So not using data means relying on assumptions that may not be accurate. And without on-the-ground site investigations, you might not have a good understanding of what is actually happening or why. And finally, without employee engagement strategies, you might miss key insights or really limit your ability to implement solutions. So we highly recommend this sort of 3-pronged approach to finding opportunities. On page 2 of the workbook that we shared with you, there is a checklist for you to indicate which of these strategies you're currently using and a space to sort of write down what you'd like to start implementing. And we will let you sort of explore that on your own. Feel free to use the workbook as we're going through and take those notes. So for this next section, we're going to explore different types of energy waste at a very high level, and I'm going to go through it pretty quickly. Just kind of to give you a picture of what it looks like and think about where it might be occurring in your facility. As we go, please follow along on page 3 of your workbook, and in the space provided, you can write down where you think this type of waste might be occurring at your facility. So here we have the 9 types of energy waste. We'll describe each of these briefly, but remember the purpose of these is not to create sort of strict definitions to fit opportunities into. They're really meant to help illustrate what waste can look like, to help you think about where opportunities might occur, and to recognize waste when you see it. So the first one is around unnecessary running or idling. It's pretty self-explanatory. It's equipment that's running when it doesn't need to be. The trick with this one is sometimes thinking about what needs to be means, right? Ovens may need to warm up before production starts, but they do need to warm up. Do they need to warm up 2 hours before production begins? Suboptimal efficiency refers to any equipment or system that isn't operating as efficiently as it could. Could efficiency be improved by upgrading the equipment or changing sequencing of other operating parameters? I'm just going to have some tea to warm up my throat a little bit here before I continue. So we have misapplication as well. It means using wasteful equipment or processes when a more efficient option is available. So using compressed air to clean clothing, it's not really a good use of that. And I think John's going to get more into that. Excuse me. We also have leaks. It's another pretty obvious area that we can imagine. Even sometimes they aren't the easiest to spot. These can occur when water, refrigerant, compressed air, heating and cooling other systems. Then we have malfunctions, which is also pretty self-explanatory, and underutilization. Finally, we have friction loss, which can happen in moving parts like motors or conveyors. A good tip is that often you'll hear this. It's noisy, but this can also include buildup within pipes or on heating transfer surfaces that limit their efficiency. And then finally, system imbalance. It can happen when there's a mismatch between what is required and what is being provided by a system. And then just to kind of give a shout out, traditional lean waste refers to inefficient production and can include defects or lost product. It can include excess processing, overproduction, and unnecessary motion, transportation, inventory, or waiting time. And the thing to keep in mind with this is often there's a lot of embedded energy in traditional lean waste. So we have another little Menti here for you to do. Again, menti.com using the code at the top of the screen. Where might lean waste, specifically lean waste, embedded energy, be occurring, or where you found it occurring in your facility already? So where do you guess it might be happening, or where have you been finding it? And we'll give it a few minutes for folks to log in their answers. Scheduling optimization. Great, we have airflow rates. So material movement through your facilities, through your processes. I know this one takes a little bit of thought off the hilt. It's something to think. Quality rejects, yeah, so you're having overproduction due to quality issues, not being able to use those things produced because they're rejected. Improper use of resources, great. Equipment changeover, definitely. Compressed gas, great. And no setbacks. Having some good examples come through, and I hope, John, you're noting some of these maybe as you thinking about for your presentation. We have, great. I think that's, oh, a couple more coming through. Weekend overtime, yeah, definitely. We hear a lot about inefficiencies with weekend scheduling and production. Often it's just not as productive or efficient as those week hours. Half runs, absolutely. Manpower movement. I love all these great manufacturing terms that we're seeing come through here. Speaking the language. Excellent. Thank you all for those great examples. So before we sort of get to this next section really quickly, we want to start thinking about what might be your significant energy users in your manufacturing processes. So these are pieces of equipment or systems in your facility that consume the most energy. So again, using the Menti, we've got a few things already identified here, but there's a space to put other. And if you do put other in this Menti for your significant energy users, I would love for you to drop what are those others in the chat. So if you can write other, but then also tell me in the chat what is your other, if you don't mind sharing. And again, we have compressed air, ventilation and exhaust, process equipment, process cooling and refrigeration, process heating, space conditioning, lighting, and then that other. I love that compressed air is number one almost.
In the shower?
Oop. Just checking in that folks are muting themselves. If you're just joining, make sure you're muted there. Process equipment, actually, we see that coming through, taking the number one spot. Definitely significant energy users within manufacturing, followed by compressed air. Then we have process cooling and refrigeration, ventilation and exhaust, space conditioning, lighting, process heating, and no one put other. Maybe you don't want to be put on the spot to share in the chat. That's okay. I'm glad we covered the basics here of what are the main ones for you. So in manufacturing facilities, you can have some very energy intensive processes. You all know this, that you want to make sure you're operating efficiently. On page 4 of the workbook, there is a list of common significant energy users and space for you to write down your top 3. You've just had some time to think about it in the Menti. There's a brief checklist of steps you can take to ensure your largest energy users are operating efficiently. So just maybe we can do like a bit of a show of hands, and there is the raise hand function at the top. How many people are able to check off all those components of managing SEUs that are on your workbook? Managing SEUs is a big component of the ISO 50001. So if you are interested in learning more about how to manage your SEUs, I suggest following the links in the workbook to some relevant sections with 50001 Ready dashboard. Save on Energy will also be adding an online video course on managing SEUs to their training site later this year. So that could be really helpful content for you to review when that comes out, and keep an eye out for it. I wanted to mention here before we kind of get turned over to John and Dan, we have prepared content for systems that are common across facilities, but we did want to indicate if you have a specific system that you want to discuss, whether that's like welding or paint booths, really specific systems, we didn't want to sort of get too niche and exclude people in the main part of our presentation. But I would love for you to make a note of those questions, or even pop the questions you have about those specific areas into the Q&A early, so that we can address those, because we're going to spend probably about 30 minutes in the Q&A and in discussion during the presentation. So please do note those specialized systems. So at this time, I'm actually going to pass it over to John and Daniel for a bit of a introduction to themselves and to Eladico before they kick off their presentation. Thank you both for joining.
Thank you very much. Before I introduce myself and John, I'm just going to provide a little update on Eladico. So Eladico Consulting was formed in 2005 with the mandate to support local LDCs with the evolution or the beginning of the Save on Energy programs and conservation funding across Ontario. Since then, we have grown into a multifaceted energy and carbon firm. We have 2 main lines of businesses. One is CDM program delivery and design. For instance, we are the technical reviewer for the ISO's industrial program, as well as direct-to-client energy and carbon management services. So in these services, it's anything from comprehensive systems audits to level 1, 2, and 3 ASHRAE audits, carbon planning and carbon roadmaps, measurement and verification activities, and then finally fractional energy management services for firms that either can't find a full-time energy manager or don't quite have the need for a full-time body. So a little bit about myself. I've been in the energy conservation industry since 2006. I originally got into the field as a industrial sales compressor representative in Windsor, and then has since then moved on to delivering conservation programs for both the ISO and local LDCs. And I'll pass it over to John now.
Thanks, Dan, and thanks, Amanda, for this opportunity. So my name is John Feldman. Some of you may recognize me from my former role as the Senior Technical Officer for the industrial programs at the IESO for the Save on Energy program. I have been a CEM or Certified Energy Manager instructor for close to 20 years. And pre my ISO life, I conducted over 100 energy audits and energy management systems at a broad range of manufacturing facilities and large industrial operations. And for those puzzling over the accent, I am originally from South Africa. I think, Amanda, you wanted to talk a little bit about workshop, the workbook. Oh, mute.
Thank you, John. Oh my
That's always
gosh.
going to happen at least once.
It is going to happen. I wanted to say thank you both for being here again. I did want to mention there is a section in the workbook. As John and Daniel are going through, do take some time to identify energy saving measures that are applicable to your facility in that workbook that we've given you. And yeah, I'm going to officially pass it over to John and Daniel to talk about their all-in approach to finding opportunities in manufacturing.
Okay, thanks again. I hope you can all see my screen because I can't see what you see. So maybe Amanda can give me a thumbs up or something. Fantastic. All right. A little bit of background before we look at some specific areas of opportunity. And the first one is both context or expectation setting and a disclaimer, in the sense that, as those of you on the call are probably painfully aware, to do a workshop on manufacturing opportunities is a challenge because manufacturing is very heterogeneous. Even two plastic molding factories can have very different process operations. As Amanda mentioned earlier, we didn't want to lose half of the audience when we talk about specific projects. So we're going to be looking at some common systems that you would generally find throughout manufacturing, and some of those were mentioned earlier, and hopefully use that as a platform to build off with specific questions and specific things that you want to know. But we're going to lay the foundation of some approaches to finding opportunities that you may not have already seen. As a side note, kind of in context setting, I did want to mention, and it's been talked about a little bit already, about employee engagement. But getting as many people involved in your facility to find energy savings opportunity is can have a huge impact. Even folks that you don't really consider as energy users or having an impact on energy are folks that can sometimes notice things that you might not notice as operations or maintenance or even energy managers. However, in order to get all of that solicited in or that help from out the organization, you may need to give some basic energy awareness training, and some of the slides that Amanda presented earlier about the different types of energy waste and lean manufacturing might help people see things that they wouldn't normally see. Another thing that if any of you have spoken to me for more than 5 minutes on the topic of energy management will hear my beef about the word energy audit, because the word audit, most people have the connotation of CRA coming to audit your finances, find things you're doing wrong, and punish you for it. And we've heard the term treasure hunts, or catch the energy thief, or energy reviews, or energy assessments are all better words for folks to understand that you're trying to get them to help make your organization better, and they should bring forth when you're asking them for opportunities or things that they have seen. So on the one side, it's important to empower staff, so that kind of ties in with that, is to make sure that everyone in the organization feels comfortable that this is not like reporting, it's not like whistleblowing, where there's risks involved in that. This is really good stuff that's going to help everyone. And that's the kind of the passive part, where you want people to bring forth ideas, but also just speaking to folks throughout the organization. I have found time and time again where there are things that bothering people about energy waste that they just don't know who to talk to. So kind of creating that environment where you can speak to people can be a huge help in finding energy opportunities in manufacturing. So having said that, let me talk about another key concept that you may be familiar with or you may not, but I want to stress us and set the first, and this is a progression, the first point to start when you're looking for energy opportunities, and in the earlier slides it spoke about the 9 areas or 9 types of energy waste. And that's really the place to start, because you may have heard the corny or cliche statement, the greenest or the cheapest or the most efficient kilowatt hour is the one that you do not use, or gigajoule for that matter. And it doesn't make sense to be purchasing more efficient equipment or maybe even renewable energy that all you're doing with that is you're blowing that energy away or you're wasting it away. You want to make sure that as much of the energy that you're procuring as possible is going towards delivering the goal of your organization, be it whatever product it is you're selling. And I'll move to the other end because that's where most organizations do tend to start, is with equipment upgrades. They want to buy a new, more efficient equipment. But there's a step before that which can be really cost effective, and that is to make sure that the equipment you do have is operating as efficiently as possible. It's maintained well, it's got the right set points, it's doing things in the right way. And we'll see these little icons that were scientifically chosen by Microsoft and their AI engine to represent these. On the opportunities with the examples that I'm going to show you, will just give you a flavor of whether this is about reducing waste or equipment upgrades. So watch out for those signs as we go along. Okay, given all of those constraints and those expectations and the fun world of manufacturing being heterogeneous or heterogeneous, however you might say it, potato, I'm going to talk about a generic form of data analysis, load duration curves and load profiles, which again, as Amanda alluded to, you can do data analysis, and I think it was one of the from one of the Menti polls that that's the big thing that we want to do. Now again, when you're looking at production data, it becomes very complex. I've only got 30 minutes to share with you my fun ideas. But I'm going to look at two simple things which you may or may not have done already that can identify things that you may not see. You're going to talk about compressed air. Could have a whole session on this, Dan and I together. But we're going to talk about poor application of compressed air. It's almost the ultimate energy waste identification. Idling equipment doesn't sound exciting, but it's surprising how often, even if you can't shut equipment off, you can set it back. Lighting is, I will talk about it, is visible, so it is a good opportunity in industrial, even if it might not have as much impact as we were saying that the process equipment is our biggest energy user. Lighting may not be, but there are advantages to doing lighting. And then pumping, kind of a more, again, looking at simple ways or relatively simple ways to look for opportunities in pumping systems, because again, most manufacturers' facilities have some form of pumping going on. So let's have a look at those. First thing, and this is in that category, that type of type of discovering opportunities by doing data analysis. All you need is hourly interval data from the utility, which these days with the green button regulations, everything above 50 kW. Again, I know some folks have challenges a little bit with their utilities, but in general, you can get this data. The only other key thing is to make sure that this matches the billing dates, because what we're after here with the low duration curve is to look for opportunities to reduce our peak demand every month. So we do have to have the billing data has to match the interval data. Two examples, and I'm going to show you a real curve, anonymized, obviously, of a facility, but just two examples of where people can do things without maybe thinking about the impact. And when I was doing some work earlier on in the US States, a lot of manufacturing facilities were required to test their fire pump or their fire water system once a month. And hey, it seemed Friday afternoon was a great time. People knocked off early to go home. At 3 o'clock, before the last person leaves, we fire up the pump for a half an hour, make sure it's working, and we gaily set our peak for the month, which could have been anywhere between 100 to 200 kilowatts for that month. Another one, a bit more on a frightening scale, but a facility that I went to where their chiller plant was for process cooling was running out of a life, I guess, and they brought the new one in and commissioned it during the summer. So we had two chiller systems running in parallel throughout the summer. The fun part is they got a $40,000 penalty for that month, but because they had something called a ratchet clause, which I won't explain, they actually had to pay that $40,000 for the following 11 months. So it was a very, very expensive scheduling thing that could have been done with better scheduling. Okay, let's have a look at a real curve, and I'm going to try my little laser pointer thing here. This is both the load profile by time versus this low duration curve, which there are fancy ways of doing low duration curves. I used to do this just by putting that interval data into an Excel spreadsheet and sorting it from biggest to smallest, and then you actually plot this curve. The key point is most facilities, or many facilities that I came across, have a very steep slope right here. And what that means, if you look across here, you can see there are very few individual instances during that month when we're going above 400 kilowatts. So we've got a 50 kilowatt gap here, and it can be surprisingly easy if you do this, and you really should do it once a week in the early days, when people remember what happened at 3 a.m. Why did we have to, what piece of equipment or pieces of equipment were started up when we were already heavily loaded. This one, I just took a stab at it. There was only 12 times in the month, more or less, and that was just by my eyes. I didn't do a fancy Excel thing. We could have saved $7,000 a year. And again, the point I'm making is these are things that you should be able to notice quite easily because they don't happen very often. A specific example I had, which I think is fairly common in the plastics molding industry, they have regrinders. And one of the beautiful things about plastic, it's a very recyclable product. So when you have offcuts and waste and rejects, you put them in a bin, you throw them into this fairly large machine, which crushes it down or grinds it down into small pellets again, and you can melt those. The problem with this facility is like laundry, you don't want to mix the darks with the lights, so they had 3 regrinders for 3 different color groups, and they had no signs or controls, so there would be always, and for the year that we looked at the data, every month there would be at least 1 hour when all 3 grinders were running at the same time at full load. Again, these were about 250 to 300 horsepower machines. A simple scheduling thing of saying you never, if you come into the room with your bucket and there's 2 grinders running already, just leave the bucket there. We'll get to it later. I will go back to saying, so I was going to mention this is about cost savings, peak demand saving. It's not truly about energy improvement, but these are things which can start some interesting conversations and interesting things that you can see when you start looking at demand challenges. I did want to pause quickly here for in the Q&A if there's, okay, no, there was another question so we got this end. I want to ask, does anyone have an idea what this end is telling us on this low duration curve? See if anyone's brave enough to type it into the Q&A or the chat. I suppose I can look at both. Because that can be another sign of something interesting to.
Yeah, I think, John, also folks can use the raise hand function if they want to answer your question, and feel free to unmute and answer the question around what this last part of the chart means.
Thank you, Alan.
Al,
I knew I could rely on you. Base load, yeah. So this is kind of saying exactly why can we never shut this facility down on the weekends all the way? What is happening here? Why do we still have, what's that, 100 kilowatts all the time? And we'll see another picture that's not even true. So this particular facility actually did better than that. So next bit of data analysis that can be quick and easy to do if you haven't done so already is doing that same load profile plot by doing it by day and start comparing why is Monday different to Tuesday, etc., etc. It may require a bit of Excel skill. I think there are also software packages that can do this for you. Just a few things I noticed, and this data is on a Friday afternoon. It looks like they shut this down, but they do it in a painfully slow way. If we look at here, we've got the Saturday where they shut things down quite well. It got down to 50 kilowatts instead of that 100 that we were looking at earlier. So that's kind of the first question you can ask when you look at these patterns. Why can we not shut this down and all go home? And then I would have thought Sunday was a non-production day, and I don't know, but it looks like we did pretty well on Saturday shutting down, and then things started creeping up. And when we got back to the same baseload on the weekend. So this type of thing can, again, a fairly simple analysis right from your interval data from your utility can help you start asking questions. Again, if you can do this on a weekly basis and going back to the operations and maintenance team, when they can still remember what was on last night or the night before, coming back a month later can be a bit of a challenge. And that is all I wanted to say about that. Okay. Hold me back, Amanda. This is one of my favorite topics, compressed air. I won't take up too much of your time, and this will start getting some more participation from the audience. I would be utterly shocked if anyone on this call has never heard about compressed air as a very expensive, or in fact the most expensive form of energy. But I wanted to kind of give you some handy numbers which might help you as you talk to folks about compressed air in your facility. Manufacturing facilities generally as about 10%, up to 10% of the energy in that facility, and we saw it again with the Menti pole, is used by compressed air. A cute little number that I learned from a fellow South African, a way of looking at compressed air is for every kilowatt of actual work that you do, that you get done moving things or doing whatever you're doing with the compressed air, you need about 5.2 kilowatts of electricity to give you that 1 kilowatt at the end. And it's like paying an 81% tax. And some people might understand tax better than they understand energy. So that could be a way of representing that. And again, as we most likely all know, compressors only between 5 and 10% effective. Someone had called it an air compressor, is really a heat generator with some compressed air as a byproduct. And if you look at the numbers, that is probably not far. Just some pretty pictures of things that are going to leak. But as I said, I'm not going to bore you with the leaks, although because most people are aware of that. What I'm also find is any facility I've ever walked into in my career, there have always still been air leak opportunities. Okay, so now what we're going to talk about is poor application. Some people call it inappropriate use. I think that sounds, I don't know. I think poor application sounds better. So one of the things you can do in your organization that can, again, not always as easy fixes as air leaks, but is to be brutal in a nice way. Be brutal in your treatment, but of the use, but not of the people. Let's put it that way. Is, do we really need compressed air for this function that it's being used for? And I saw Max, you'd kind of spoken about how do you put the cost and benefits to that, and that's another question which we'll try our best to deal with in the Q&A. But trying to, and sometimes just having a compressed air leak table can be a good way of estimating, if this compressed air use was just a leak, what is the cost of that of using compressed air for this application, and then look at the cost and energy use of a suitable replacement. And then as an organization, you can decide, is compressed air really worth it to use it? Because it's an ongoing thing for years and years. You're going to pay that high price for compressed air. Is there something you can do? Some general examples, and then we'll have some specific examples that I've seen, and then we can talk about things that you may have seen of where there are poor applications of compressed air. Anywhere where you've got open blowing or drying, most facilities you'll come across have these portable air guns or air lancers that are really being used to blow dust around or blow things around. Having low pressure blowers and fans with engineered nozzles can be a much more energy efficient way. Maybe not as much in manufacturing, but you do get this where you're either aerating some kind of liquid by blowing air through it, or just agitating it. Having a mixer, way more energy, less intensive than blowing things, or just having low pressure blower. There was once at a mine site that had a 10-meter slurry of nickel metal slurry, which was incredibly dense. And that was the only time I've ever seen where you really needed that compressed air pressure to get the bubbles up through it. Most other water and liquids, you really don't need that kind of pressure. A simple little thing that you may find on shop floors is cooling, having a little compressor line into a PLC cabinet to keep the dust out and to cool it. Again, refrigerated cabinet coolers are a way more energy efficient way. Air motors. I know Alan's here in automotive. Ubiquitous use in manufacturing where you have air tools, wrenches, and drills. Use a lot. There are some good advantages of them, but I have seen a lot of electric motor. They tend to be bigger tools, and I've seen most of them have a wire that's hanging down from the ceiling to help the operator. But again, over the lifetime, even of an automotive cycle, using the electrical equivalent wrench compared to compressed air is frighteningly more expensive. Again, I will, for liability and other reasons, mention that there are some times when air motors, well, one of the times where it's hard to get away from air motors is where you've got an explosive environment, because if you have a spark that's going to set your building alight, you don't want to have that, and that air pumps can be, air motors and air pumps can be absolutely required. Another thing I've seen in manufacturing is Venturi vacuums. That's where, particularly when you're moving pallets, the cardboard boxes and packaging, they'll have these machines that have these Venturi vacuums that suck things up. Again, very inefficient way. Rather have a vacuum pump, even a central vacuum pump, or maybe a small local vacuum pump, is much more energy efficient. And then Amanda already mentioned this, but do not blow air off yourself. It's dangerous. And also, compressed air used for cooling is it's just not a good. You feel like you're blowing a lot of air, but that air is hot. It's not a good way. One of the worst things I had seen, and I'm going to ask you for your things that you have seen in a minute. One of the worst cases I saw was a large fan in an industrial facility that actually had compressed air as part of the design and was ducted to cool the bearings of this fan. It wasn't as an afterthought. It was actually part of the design. We were going to use compressed air to cool the bearings. You'll also find in manufacturing a lot of product movement where you're pushing things to one side of a roller conveyor, or you're hitting rejects with the compressed air. Again, very expensive because that air is blowing a lot of the time. And it is, again, it's an expensive way of doing it, that whereas mechanical can be a lot cheaper. And what was I going to say? That was the end of my tirade. What else have you seen from the field of what I would say poor applications of compressed air, or expensive applications of compressed air? While I take a sip of my tea. Tom has got a few things. sorry, I shouldn't laugh at that. Yeah, compressed air being used to cool the compressed air motor. I have actually seen that kind of thing. Yeah, thanks, Tom. Anyone else? I'm assuming this is the same Tom that was on my panel at AE World a couple of weeks ago. So
I think there might be something, John, coming
new
through
posts
in the chat as well. Check the chat as well as the Q&A.
You're not making things easy for me, are we? Okay. Continuous blow on packaging line to keep flaps open. Yep. Leakages.
Yeah.
There is, and that's the frightening thing, I think, from. Why can't I see the name? There, Alateo. Is I've seen a lot of that where compressed air is blowing all the time, but it's even just having a little solenoid valve to blow it when you need it. Well done. I'm glad you're all awake and you're participating. That's going to make this making the Q&A time a lot more fun and helpful, and we're going to be in good shape. All right, moving off the fun world of compressed, well, not quite that. Why is this not working? Just again to frighten you with numbers from the large industrial world that I spent a lot of time in. This was a design system to use Venturi air blowers to cool underground in a mine in a very hot environment. Again, the coefficient of performance sucks at 0.1. There was the opportunity to put in a portable refrigeration system which actually cooled the air using the vapor compression cycle. And the savings were just frightening. 1600 kilowatts for the Venturi air blowing to try and sort of cool, but not really. And versus 52 kilowatts for a little refrigeration unit, saving them $700,000 a year, which should pay for a small refrigeration unit many times over. Again, I hope you don't mind me bringing some large industrial frightening numbers. Your numbers may not be as frightening, but these things can add up. Okay. This is under the category of employee strategies. Turn that thing off. Again, it sounds so simple. Why isn't everyone doing it? Sometimes there's a few reasons that I have found why people don't turn things off, and we're talking again about process equipment and not so much lighting, but that's also a thing. The most efficient light is the one that's off when you don't need it. Don't just put the place in darkness. That would not be a good idea. But first of all, there are some pieces of equipment and motors that don't like being turned off, but it's quite a process to get the equipment back up and running. Often that equipment can just be turned down or idled. So you don't have to completely start it up, but you're not running it at full capacity when there is no production. The other thing that I've seen often is where people have implemented step one and have actually shut down the process, the manufacturing equipment or the process line, is they forget about the services. Might be compressed air, lighting, cooling water, various other bits of service equipment that should be turned off as well. Why do you want to be pumping water through a system that's not in production? And certainly, why do you want to be servicing any air leaks from equipment that's not producing your end product? And the other one is I used to get pushback when I happened to walk into a facility. There was the folks were on break for a 15-minute tea break or whatever break they have, and all the equipment is running. And the question was, well, it's only 15 minutes. It's not worth the effort. Well, those 15 minutes over a year, in my sort of basic assumptions, could be 200 hours a year, and you times that in terms of kilowatts at that facility. If it's as simple as turning it off, all those little bits can add up to big savings, or to maybe big savings is a strong word, but to substantial savings. I will say there are sometimes equipment that cannot be turned off. The only one out of all those hundreds of audits I did that really had an issue that could not be turned off on the weekend was a wire annealing furnace that has ceramics in, and it takes about 16 to 20 hours to warm that thing up slowly enough so things don't crack. So they literally could not even turn it down or turn it off over the weekends. So unless you have an example that's even worse than that, I would challenge you to find ways to turn equipment off. Some of you may identify with this is automotive assembly line cooling fans for the operators that are just left on all day, all night, because it's hard to get people to turn them off. And we can work on that. We spoke earlier about the people side. Another thing, particularly in wood products facilities, but there are a lot of manufacturing operations that have bag houses with dust collection, and that dust collection system only has one volume or one speed, and that's full speed. And even if there are workstations or production lines or unit operations that are not operating, it is still sucking air from that. Again, a little bit more of not complicated, but it's not straightforward to blank off the ducts and have you need to have a VFD to slow things down. But it's again what I found an often overlooked opportunity. And one of my favorites ones, which just annoys me, is where you have product conveyors, or typically roller conveyors, where you're moving product and they might be sectional. And I walk in the facility and I see there's nothing on that conveyor and it's buzzing away. And the pushback is always, well, John, you just caught us at the wrong moment. The product's coming over the hill. It's about to be there. And sometimes those conveyors run very fast, so you may not be able to turn them off and ramp them up quickly enough again. But again, if you can idle them down, you're saving energy, and you're only running at that when you're making product. Also seen sometimes shift operators will come in at the end of the weekend, early on a Monday morning, and just turn everything on so that it's all running and heated up and whatever the case might be, but rather scheduling that, work out what the startup time is or the heat up time is, and make sure you start that equipment just before it's, or not just before it's, but only with that warm up time before you use it, are the type of things that you can look for. So again, I will look in the chat and the Q&A. Anything you have seen that really should have been turned off, there was no valid reason that it couldn't be, or maybe you can share some things where it looked like it could be turned off, but there was a really compelling reason why it couldn't. If the chat is going to light up, or
While we're waiting for that, John,
yeah.
I had an example out in the field where it was a warehouse separate from the main building, and all of the high bay lights were on breakers. The staff in the building could not turn them off because they had to have a team electrician flip the breakers, and they didn't want to bring people in at night to turn them off. So these lights ran 24/7, even though it was only a one shift operation, just over the fact of someone couldn't turn them off.
That is actually a good point. Is I have been to a lot of mining facilities where they have their MCC, their motor control room, 100 light bulb, 100 fluorescent lights. Person comes in there twice a shift to check something, and they don't actually have a light switch. You can't turn the lights off. It was I don't know if they thought electricity was free, but yeah, that can sometimes, I should have mentioned that, sometimes there's a very fundamental challenge with turning equipment off. There's no switch. No one ever thought it would have to be turned off.
John, sorry to interrupt. I want to make sure Max mentioned in the chat lab ovens being one thing that he finds left on. So maybe that falls into that category of difficult to turn off or can't turn off or something like this, but this is one thing he mentioned.
That's a good point, and I think from my experience with not in Max's world, but sometimes those ovens are just left on, and they don't actually take that long to heat up if you know when you're doing your quality tests or whatever. And another one that I found, which was annoying, and I couldn't get a really good answer to solve their problem, and it seems small, but it kind of gives that send the signal, is in a canteen in a very small facility, but they had one of those toasters that like you have at hotels where it's a little rotating wire belt and you put the toast on, and that's just running 24/7 because someone may just have the urge on midnight shift to have a slice of toast, and that is a thing that yeah, it's people get it because if you turn it on, it's got to heat up and the belt's got to go, and people, they can't wait for their toast. So I didn't win that battle. All right. Maybe I'm too intimidating, but we're didn't see anything else in the Q&A or in the chat of examples. So maybe people are saving it for the actual Q&A. All right. One. Does my thing not work? Just a couple of examples from my side that I put in the slides for turning things off. An automotive trim facility that had 30 machines for fusing. Again, we've spoken a bit about this. Had electric heat bases, but again, the units are just turned on when the start of the production day, and you may or may not. You certainly won't use 30 machines all the time. And then I love this other one because this is a bonus. This is compressed air and turning off all combined into one. And this happens very often in extrusion in the plastics industry, where you've got extrusion products that are cooled by spray water, and then there's compressed air to blow the water off to dry it. But the compressed air is on continually, whether there's extrusion products coming or not. So the solution was twofold. One is to, first of all, to interlock so that when there's no extrusion happening, the compressed air is shut off, but then also replacing that compressed air as a poor use of compressed air with a low pressure blower, and get a double win on that one. All right, lighting. As I said, maybe I didn't, so I'll say it now, is Lighting tends to be not super exciting in industrial because it tends to form a small percentage of the energy use. However, and excuse the pun, it's deliberate, lighting is visible. So as I spoke on earlier, where you're wanting to try and engage all your staff and make energy management everyone's part of the business and everyone's business, is when you do energy efficient lighting replacements, it's visible. People see, they can't see the compressor, they can't see the pump improvements. Hopefully they can see you turning equipment off. That's another one that has a double effect. Not only do you save energy, but you helping people see that as an organization you're serious about energy management. Lighting is very visible. When people see the lighting improvements, it helps remind them every time they walk in the facility that energy efficiency is important. From a business case point of view, industrial fixtures, particularly some of the specialized lighting, can be quite expensive, but bear in mind that not only do you save energy, but generally, particularly for LEDs, you're saving the maintenance or the relamping costs. You don't have to relamp. And particularly, maybe even less so in commercial buildings, but very much in industrial, often those lights are expensive to change because you have to shut down equipment, you have to get a genie lift in. There is you would typically change all the light bulbs at once, but if you only have to change them every 5 years instead of every 2 years, that can be substantial savings to build into the business case. And then remember that your air conditioning will also come down weather normalized because you're not generating as much heat from your LEDs. The particular example you see on your screen, there is also the other component, which is the utility incentive rebate. So in the real world, when you're doing lighting, what you gain much more generally on the summer cooling savings, but now because you don't have the heat from your lamps as much, you have to supplement the heating in the winter. And in a good, again, this wasn't included here because it was the electrical utility rebate, but in the real world of energy management, lighting also has an impact on increased heating. One of the most, and again, this could, the last bullet could apply to any of these type of capital improvements, is something that can be helpful to tell your organization or the management is every month that we don't do this, we're spending an extra X amount on energy. So just bear that in mind as you decide, how much to accelerate the project. One of the most fun ones I saw, and we spoke again about if you can turn lights off, that is the very effective way to save energy. A warehouse. I think it was a parts warehouse because there wasn't that much forklift traffic, but they had, just like they have in the Star Wars corridors, they had occupancy sensors in the high bay lights, and as the truck drove in, the lights would bing, 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 bing on. As it left, one very short time, as I think there was some minimum lighting so the forklift didn't drive into a pallet before the lights came on. But again, just a kind of cool thing that's not that challenging to do. I will warn you, there was one other one that has come to mind where this backfired. Is there was a plastics facility, and I'm not going to draw it for you, but they had an L-shaped facility, and in the corner of the L, they had the parts warehouse. It wasn't that big, and they had occupancy sensors installed in there because they said it's a parts warehouse. People are hardly ever go in there, but unfortunately, that was the shortcut to get from here to there. So everyone walked through this parts warehouse and the lights were on all the time anyway. So sometimes you have to think things through a little bit and account for human ingenuity, if I can put it that way. Okay, my final thought is on pumps. Pumps are a unique process measure in the sense, not unique. There's an easy part to pumps and a difficult part. Getting a pump to operate at the best efficiency point and do impeller trimming and analysis of the whole system requires some specialized knowledge, and it's often best to consult experts to do that. But there's an easy side of pumping, which is the more resistance you have to the flow in your system, the more energy you're going to use to pump. And it is surprising what you will find out there. We spoke already about shutting off process cooling water to equipment. Sometimes I've been in facilities where they had old decommissioned machinery that still was linked up to the process cooling water, and it was being pumped through continuously. So again, sometimes it's unused, it's permanently unused equipment. Sometimes it's just equipment that's not used right now. If you tie that in with a pump with a VFD, there can be savings there. Sometimes, and this happens with compressed air as well, but sometimes the water cooling was put in right at the end of the manufacturing, and there are bends and twists in the piping just to get it through to another place. Every time you bend and twist a pipe, you're increasing the resistance to flow. You're having to spend more energy on pumping. Pipes fouled over time. You can get, depending on what liquid or what fluid you're pumping, they can get, if they're not clean, they can build up quite badly. And I show an example on the right of an extreme example again in a mine that was pumping dirty slurry water, where they managed over a few years to reduce, because they did something silly, which we can talk about in the Q&A if you're interested. It takes a bit of explanation, but they managed to reduce a 6-inch pipe to a 1/2-inch diameter that was just crud. Again, the reason they noticed that was that there was no water coming out the other end. It wasn't an energy efficiency idea. And also sometimes, and I did see this before, of where you can sometimes pump things because of the history of how the building was built. You're pumping stuff up to the 3rd floor, and then you're letting it back down again. That creates energy that you don't need to do. Again, a golden rule, if you haven't done this before, is wherever you have in your piping, your pumping system, have a throttling valve, either manual or controlled valve. That could be a good opportunity, and is often a good opportunity for a VFD. There are certain situations where that may not help. One of the most that brought me to tears, but was really interesting, was that a plastics molding. Actually, I can't remember what it was. A plastics factory. They built. It was pretty brand new. They built it in 2 phases. The first phase, the process cooling water, there wasn't enough flow for the pump, the suction. The pump was cavitating because there wasn't enough suction on the side. So what they did is they put in a bypass loop with a valve, and so they could provide enough flow on the inlet of the pump so that it would work. Of course, when they commissioned the second part of the facility and had the full flow, no one remembered about this bypass pipe, which had a valve, it had a valve because they were meant to shut it off when they commissioned the next facility. So they were pumping, 50% more liquid through that pump than was required, and what that was designed to do. And again, the way they found that out wasn't from energy use, but from the fact that they'd burnt out their 3-year-old motor already. And I saw it there. I saw there was a brand new motor, and the other one was running at 75 degrees C and was about to go too. Simple solution: close the valve on the bypass, and the world was a beautiful place. And I am now just about at my last slide. Just again, every now and then you'll see I do this, some frightening numbers from bigger projects. Essentially had a bunch of pumps in a cooling water circuit. Production facility was 8760, but there was opportunity for 3,000 hours, around about 3,000 hours of non-production, where you still needed some flow, but not all of the flow, and an efficiency pump efficiency upgrade combined with VFDs saved about $170,000 an hour. And that, Amanda, is the end of my ideas and presentation. And now we're going to go to the fun of Q&A. I'm going to kill the slides so that we can see people's faces, and I can see the questions more easily.
John, before we get it, I would like to address Max's comment, because I think I seen that a lot when I was in the field. Is you're 100% right. Compressed air, especially on new builds, is often an afterthought. A lot of the times they're not properly engineered. Ball valves is one thing that I find that people A lot of the times they cheap out at the upfront and they don't put ball valves, bypasses in, which causes problems down the road. As well as when you're designing it, instead of putting a coupling in, spend the extra few dollars and put a T with a plug in it. That way, then you've always got future capabilities of tying in plant or tying in new equipment. So definitely, I think that's one of the things there that I see the most of is just overlooking compressed air at the design phase. And then because people think it's cheap, they tie it in everywhere.
Yep. Air is free. You breathe it. So it's got to be free, right? Sorry, that was sarcasm. It's very expensive. But again, people have this idea in their head sometimes. So Amanda, are you going to manage the question and answering? Or
Yeah, I mean, I definitely can. I think there was a few things that I noted in the Q&A that came up. One of the more recent ones was a question around lifetime performance of LEDs. So you were talking about lighting, John, earlier, and finding opportunities in lighting. I think many opportunities in lighting, especially when you're replacing incandescents with LEDs. But Max was curious about people's experience with LEDs dimming over time, or if people found issues with this. And I think related to that, Max was also asking about thinking about return on investment and calculating costs. And I did want to quickly plug that there is a workshop coming up. I put information in the chat specifically on process cooling, but often there are workshops on finding energy saving. So watch out for the calendar for that. And I will, John, let you address this question of LEDs if you have experience with that.
So I don't have direct experience. I have vicarious experience through others. However, there is that caveat emptor, buyer beware. There are high quality LEDs and there are not as great LEDs. So generally LEDs that are Energy Star or Design Light Consortium should be able to, and our Underwriters Lab certified, should last for as long as they say they do. Now, one of the things is, unlike some other lighting types where the lumens loss over time has a funny shaped curve, sometimes they do it loses lumens quickly and then flattens out. Sometimes it lasts for a long time, and then LEDs are fairly linear. They just slowly, like they say, old professors never die. They simply lose their faculties. Sorry, bad joke. But what you generally have to do with, and this is the one I've seen a demonstration of, is you have, because you want the lights to meet the lumen, the lux values in the facility, is you actually have to design them brighter in the beginning so that by the time the 10,000 hours or the 15,000 run out, you've still got lights which are bright enough for your facility. But what's great about that is you can then, when the lights are at their brightest, you put in, you can dim them in the system so that they're at the same light output that they will be at the end of their life. And then every month or every quarter, as the lights start fading, you bump up the light level so that you're still meeting your requirements, but you're actually, in the early years, while the lights are brighter than they need to be, you're saving energy. I don't know if without my hands I explained that well enough, but maybe Max can give me a thumbs up or something to say that made. Oh, I thought there was something else Max added though.
Yeah, Max was saying the LED lighting lasts long without blowing, but the lighting level seems to drop quite drastically, which I think is what you were talking about addressing with having a brighter lighting design early on in preparation for that potential dimming that happens later in the life cycle. And then Thomas Sherman was mentioning that managing the heat generated by the driver is key for lamp and fixture design. So Thomas might have some more experience there. So
yeah, there was, so sorry, just while we're on that topic, two things. One is, yes, the LED, from what I understand, and Tom may be able to butt in, should have a lamp a test that shows what that lamp depreciation, or lumen depreciation is expected to be. And if it's dimming faster than that, there's something wrong. And I think Tom is right that it's often, if you don't get rid of the heat, that is the number one enemy of LED lights, particularly in the industrial scale, is heat, because that makes them, again, as Max said, the LED lights don't really blow; they slowly get worse.
The other thing that I've come across is just regular maintenance. If you get lights that have been up there for 5, 6, 10 years and it's an dusty environment, they just get a buildup of dust and crud on top of them. That's not cleaned. With HPSs, because you're up there often, people will end up cleaning the lenses. They'll clean the reflectors. Sometimes that doesn't happen with the LEDs. So that'll also compound the degrading in light capacity.
Sorry. Go ahead,
go ahead, John. No, if you're going to talk about anything relighting, then I would say continue.
No, I wasn't. I was going to go to Max's questions about motors on equipment.
Yeah, I was going to mention that. So Max was looking for more specific information about process motors on F&B, food and bev production equipment. So fillers, packers, mixers. I think that was just a general call out from when I was mentioning if you have specifics that you're looking at right now, please do put them in the chat. So I don't know if there's specific questions for Max, but John, if you have experience on that, that you can offer.
Experience of not having experience. So let me explain that. That came out all the wrong way. Is generally OEM pack equipment, and that from plastic molding to food and beverage, if the motor is part of that unit, don't touch it with a barge pole because it'll void warranties. It's best. It's just sometimes, particularly with process equipment, that motor is a very specific, could even be custom built to work with that process equipment. And just saying, I'm going to shove a VFD in there, generally doesn't work that well. For those things, we'd have to go back. It's best to go back to the manufacturer. I would say even over going back to a food and beverage consultant or specialist, because at the end of the day, if the manufacturer won't let you do any stuff to that motor, they are the source, and sometimes you may have to make them explain to language that they understand that you really need them to put in a more efficient motor or to put in a more process, because they may not care. They may sell one piece of equipment to you in thousands around the world, but that is a challenge. Max is dealing with OEM motors in packaged or packaged equipment, I think is the way I could put it.
I think there wasn't any more questions. There was some. I think I addressed. Well, I don't know if you wanted to talk at all about calculating cost savings. I do think that's a bit of a separate thing versus finding opportunities. So maybe we can have Max maybe come out to one of those workshops in the future. But I did want to mention, so Thomas was talking about phantom load. I think this was from earlier in the presentation. Yes. AC or heat set points, night lights, computers, clocks, alarms, plug loads, and equipment left running. I'm wondering, John, specifically, what are some of your tips for dealing with these challenges around phantom load in facilities where you have quite a big pull in the weekend and evening hours, non-operating hours?
Yeah. I haven't had a lot of direct experience, and maybe Dan has seen this. One of the things that, sometimes it's hard to, in my ideal dream world, I would go to the circuit breaker on the weekend and turn all of those computers and things off, and power surges be damned. But I wouldn't do that. So maybe doing an inventory of what those phantom loads are and figuring out there are various forms of these what kind of things, smart power bars that can be programmed, or you can turn equipment off. The other thing that I think can be helpful in those situations is you do get, and I have one stashed away here, but actually I might be able to get to it real easy. And see if it'll see, have these little things, which is you can plug into a normal plug. This one, I think, doesn't have, some of these actually have, you can program in your electricity rate, but this can be, because for plug loads, you don't actually have to go and get a power quality meter and clamp it on. You can just look, is this worth bothering about? Or, if it's one particular lamp, maybe not. But if you're in a, for example, that automotive fans, if you can total them all up. And so this can be one way of just kind of quantifying, in spite of my just do it. Sometimes these are things where part of the motivating people to turn. I mean, maybe that's the ultimate thing, is plug loads, is to getting to people to turn it off. And I'm not going to admit the organization I worked with who did this, but and it brought tears to my eyes again. There was an organization that I worked with that required you not to turn off your computer at night because IT would do their updates on some random one night in a month. They would randomly bitch, so you had to have your computer on all the time, otherwise you would miss the exciting update. And that's another thing that you can run into. But getting people to
common.
Plug those off. Yeah.
Yeah, I've experienced that as well on a sustainability team, wanting to turn things down and having some struggles with IT around that. So I think that's not only one facility, John. That's probably a few that face that.
I just want to hop in here for a second
Yeah,
too.
Dan,
I think like on
please.
the phantom load and stuff like that, it's important for management and energy managers to experience the plant on all 3 shifts or the number of shifts that they operate, and get to know what the shutdown procedures are, say on the midnight shift, and why stuff is done the way it is. Because a lot of the times it may not be, you run into that caveat again where this is how we've always done it. So I always encourage people to find out what's done on the floor, because that a lot of the times will explain why stuff is being done or not being done.
Yeah,
sorry, go.
No, go ahead, John.
I was going to jump in. Tom's comment. Yeah, there's doing these midnight or weekend midnight madness audits, showing up in the middle of the night, can be painful, but you can find all sorts of things. I've also heard folks that go, well, 2 things. One, organizations that when you're a 5-shift operation or even a 6-shift operation, if you can go in during non-production hours and have a walkthrough, listen for leaks. Often people do that with a compressed air, listen for compressed air leaks. Although I would encourage using a leak detector, because anything under a 1/8 inch leak, you can't, even if the facility is quiet, you can't hear that with your naked ear. Is that the natural ear? I don't know. There's unamplified ear. And then, secondly, there's equipment running. Like, why is that fan? Is nothing. We're not producing. Why that's? I've heard some great, I wouldn't say horror stories, but great success stories of just taking the time to get a group of people, buy them pizza, pay them overtime, and go through that facility and have fun looking for stuff that's on. But of course, it doesn't help one-off finding those things that are on. You need to get people on board to turn them. You can shut them off on that weekend, but the next weekend it doesn't help if they're all on again. So you have to address the root cause. Root cause is a bit of a strong thing, but get a process in place to say this equipment really needs to be shut off. One of the things I haven't seen recently, but I used to see in the good old days, organizations, mainly for large bits of equipment, because the numbers are more frightening, but they would have a label on the piece of equipment that says for every 8 hours that this equipment is running, it's costing $17 or whatever the case might be. So people go like, do I really need to have this? I could buy myself 3 latte macchiato things, whatever, for the price of that. And that was another thing that I found interesting. Some organizations, they don't save a lot necessarily from some of these low cost opportunities to affect the budget or make the company really excited. but a few years back, when I think around about was it the 2008 crash, companies would cancel like the staff barbecue because they couldn't afford it. But hey, we saved enough energy to have a staff Christmas barbecue this year, and that can go a long way to engaging people to say I'm saving energy. It's maybe not changing the profitability of the company, but I get to have my barbecue. Anyway.
Yeah, so I wanted to, we have about, I think, 9 minutes left, maybe 8 minutes because we have a couple closing slides. But I want to make sure if anyone has any burning questions that they haven't typed in the Q&A or haven't typed in the chat about their specific situation, their processes, their facilities. Now is your chance to do it. Now or never, so to speak. So
Now or
please
later,
do.
isn't it, Amanda? We said we'd answer things later if it came up.
Well, if there's something, yeah, yes.
Yeah.
If there's something, I think
you get a live response now.
Yes.
Or you get to see John squirm. One of the two. Either of those are very helpful.
John and Amanda squirm. But yeah, feel free to unmute or raise your hand, or if you're shy, you can go ahead and type it in the chat before we move on. Thank you, David, for sharing that resource in the chat there. It's pretty quiet, John. I don't know.
Yeah, well, there's the question there from Alex about are there guidelines or a framework to calculate losses from redundant piping, too many bends, etc. Nothing comes off the top of my head as readily available. I think we can look into that. I know Natural Resources Canada at one stage had a
compressed air challenge also has a lot of charts on their website that'll help you with air loss through bends, reductions in pipe and stuff like that.
Yeah.
One of the things to keep in mind though is, when you mentioned about the 5%, I think one of the comments was 5% is all you can hear for leaks. A simple 1/4 inch leak at 100 PSI is equivalent to about 100 CFM or a 20 kilowatt compressor. And when you start going around, especially a large plant, you got to think of how many inches of total leakage do you have in there. So it is something that can, those small little leaks add up to big dollars.
Thanks for that, Max. But and back to Alex quickly. That again, I'm sure somebody has done something like that because it's basic engineering. Each, the pressure drop that you would have over a given pipe size. So I'm sure there are ways, relatively easy ways out there. And I think if it's as Dan said, if it's relating to compressed air, the US DOE's compressed air challenge has a lot of information. Yep. So there might be a fairly straightforward conversion for that if you have that for compressed air, because water is just another type of fluid. It may not be that different. In fact, that compressed air might be if you have the formula, might be a good starting point as an estimate. And the US DOE also have, and I haven't really ever used it in the real world. It's called MEASUR, measure. And I'm trying to think for the life of me what that stands for. But they have a whole pump system module that has way too much detail for my liking. But that would probably be, I would be shocked. And I'm not easily shocked. No, actually I am. If the measure tool from the DOE did not have the ability to do what, Alex, what you're asking is saying, here's what my pipe network looks like. Here's the fluid I'm pumping. What could I gain by straightening these things? One other thing, sorry, I know, Amanda, you need to get your last final words of joy out, but I suspect you would find this on a Google search, but I was at an ACEEE conference a few years back. A guy called Avery someone help me. Avery Lovins. I think I will get Amanda the right name. It's called the Rocky Mountain Institute. They've done some weird stuff. Well, sorry, energy efficiency things. But one thing at this ACEEE conference that really fascinated, they did some tests on a water or piping system that consisted entirely of Y splits. So there's no bends. You just split the pipe and you split it again and it all comes back. And it was something, it used something like 30% of the energy that you would use with a conventional piping network. And the way that you, in order to get that system to work, is contrary to normal practice, is you put in the water system first, not the production equipment. And then you place the production equipment where those pipes are, which is wild. But hey, you're going to pay for that location of the equipment once. You're going to pay for the energy in that water pumping for decades to come. So I will try and find the reference and get that to Amanda. But that was a fascinating. I found that fascinating. You might all find it dull and boring.
No, thank you, John. That's great. And I think we can also check back on that question. So like you mentioned, maybe we'll do a little check back. I just checked in with a few of our coaches at our team as well, and we'll see if folks have resources that they would recommend. And we can send those out, Alex. Thank you for the question. I think, so we've got a couple minutes and I've just got a few little closing slides here. I did want to do a plug to the Save on Energy Management Excellence Awards. So there is still time to register for this. It's on Tuesday, October 29th at 8 a.m. to 4 p.m. in Mississauga. So you can scan the link here to register for that if you are interested. And Fatema has also put the link in the chat to make it easy for you. I also want to mention that Save on Energy is pleased to offer support from energy management and subject matter experts to help you achieve your energy saving and GHG reduction goals. So who is eligible for this? The new support is available to individuals who are involved in managing energy at industrial, commercial facilities, including, multi-unit residential and institutional facilities in Ontario. Topics that are covered, they help you address questions related to establishing or improving energy management best practices. So if you want to reduce your energy consumption costs or GHG emissions, but are not sure where to start, this is a great place for you to join and get involved. There's so many great resources as is shown on the screen here. And finally, I did want to mention, we love for us to think about, hopefully there were some things that you took away from this and some ideas that you want to think about implementing either in your processes for finding opportunities or maybe for addressing some of those opportunities that you already sort of know exist. So on page 6 of your workbook, you can make a bit of a commitment to 3 things you're going to start and really decide on your time frame for what that might be. It's really great to make a commitment after these workshops. It helps to kind of manifest those things into the future and make them happen. And if you want to share one thing that you'd like to commit to in the next week, you can pop that into the chat on your way out as you're saying goodbye. And I just really want to extend a huge thank you to John and to Daniel for showing up today and for doing a great presentation and Q&A. And thank you for Fatema, and thank you to everyone who joined us today. So thanks so much, and we look forward to seeing you next time.
Thanks, Amanda. Thanks, Fatema. Thanks, Dan. And to all of you, keep up the great work. Saving the planet 1 kilowatt hour and 1 gigajoule at a time.